speaking? Joel, anyone?
I'm here, Vincent. I can get you clearly.
Yes,
And
you can hear me well?
yes.
Okay. Yeah, so for the purpose of this today, because we want to finish up the training, I would like us to open our R script. And when you open R script, of course, the first thing you do is to run the libraries that are there. For example, the library, we need to run the library that we had set up. There's this library called dplyr library. This dplyr library is very useful for manipulating data. So some people may have to run the library again, others at times, but it's always good to load the library. So I want us to load the library, the packages. This one is especially called dplyr. So just put your cursor on the library called dplyr and then run it. It will allow us to manipulate the data. Or you can just highlight all of them. Just highlight foreign, Haven, dplyr, read Excel. Just rerun it so that you are sure that those packages are installed. So just run that quickly. Yeah, so can you run that? And then please make sure that that you have the data set. So how do you get the data set? So for some of you who do not have the data set, you have to import the data. Just check your global environment. Just check your global environment and ensure that it is there, that synthetic data is there. Remember yesterday we created another data set. And for those of you who have this data set, make sure you run it. Must make sure the data set is there. Sorry? Sorry?
We can't find it in the global environment.
You?
Yes, I can't find the data set in the global environment.
You can't find it?
Yes.
That's what I'm saying. You need to import the data. Make sure the data is there. If you don't have the data in the global environment, make sure you import the data, and you know how now you should know how to import your data set. You go to file, or you come here to the global environment, you import the data set from reader, because we are using CSV, you click on from text, read R, and then you import the data set as we said. You browse, you click browse, and then you identify your file, which is in day1 folder. You have a data set.
Yeah, I can hear you.
Sorry?
I can hear you.
I'm saying you import the data set called synthetic depression missing data. Have you done that? Joel, can you hear me?
Yes, we can hear you clearly.
So for those of you who have not imported the data, please import the data. Open the data, you just click open and you wait and the data is loaded on the on your interface, and then you click import. And once you import the data, remember that you are importing the data fresh. That means all the work that you did yesterday of transforming the variables, those ones are not available. Now, this is a raw data set. So you need to go through your syntax and some of the things that change the data. For example, you go down your script and one of the things you need to do, you check anywhere where you are making a change to the data set. For example, there was this code we wrote yesterday where we were saying, make correction to the employment T1. So we need to rerun that code so that employment is cleaned. So all the commands that transform the data, like this one, we wrote it and said where there was a typo on the employed, we ended up modifying it. Remember, if you want to use a new data set, then if we have worked on an old data set, then you need to save it as a new data set so that you have a more clean data set. But if you're working from the old raw data set, then each time you come to your raw data set, you have to run this, make sure that is done, then make correction to the unemployment variable T1, ensure that run that one again so that you sort out the employed. We did that yesterday, and you check if the output on the console is there. Employed is 9428, unemployed is 572. Check any place where you did a modification. One of the modifications we did, we created a categorical variable, 35 years and below, which we renamed as a youth. And those who are 35 years and above, we named this. So we had 3 categories. So we had young adults. Sorry. We had young adults, which we coded. Young adults, we coded those who are 1, those who are 18 to 34 years. Then those who are 35 and 49, we coded 2 years. Those who are 50 years and above, we coded 3. And we went through this process. So there's a command here, there's a code here we wrote where we said we created a new variable in the data set by assigning age cut to null. And then we assigned 35, less than 35, we assigned 1, 35 to 49 to 50 to 49, we assigned 2. So you run that. You can rerun that, including the tabulation. Table is just to generate frequencies of the new variable created, age cut. Daniel, you can hear me well? Joel?
We can hear you, Vincent.
Okay, so are we together? Are you able to do what I'm doing?
Yeah, but I have one challenge here, Doc. And the challenge is really on like after you have imported the data. The window now keeps on now being visible in the encrypt R script new window. How will I like exit?
Yeah, so you know when, yeah, so when you import, for example, when you import, by default, it will be displayed on your window, right?
Yes.
But remember, there are buttons up here. There is a new window. So you remember there are other windows here. So if you check at the top of your screen, you will see my script, you will see other things. So you just move away from that window, and there are other windows where you write your script. There are other things here. So you can exit, you can just leave it there, open the other window, or you can close it. But look at the up here, you'll see other windows. So every time you open a new data set, it opens a new window. So it will block your screen. So you just go back to there is another window here. Are you seeing it?
Yes.
So click your script. So leave alone the one where the data is shown. And you can always close that data. So run that.
Thank you.
And then we came down somewhere yesterday and we installed a package called Table 1. So you can actually run the library called Table 1. So run it. That is to make sure that Table 1 is there. If you can't install Table 1 from the command, sometimes the Table 1 refuses to run. You can go to the directory, the directory folder, and click packages on your top left, and you click install, and then you type Table 1. It's a new package that we discovered. Please run it and install it. And for those of you who wanted to update their R, maybe you are using an older R, I said there's a package called install R, which some of you can install. Not everyone needs to do this. What it does is just to make sure that some of the components of R is updated. So you do that. So all these things we did yesterday were trying to run descriptive statistics. So these ones do not modify the data. These ones technically are just outputs that we wanted. So we wrote all these codes. We are looking for any place where we are creating, modifying the data. I can see we have another one here where we were labeling. We are now creating labels for age cut. And what we did is that the age cut variable we created labels. So if it is 1, we coded it young, we label it young. If it's 2, we label it mid. And if it is 3, we label. So this command modifies the data. So we run it again. So let me run it again. So my Table 1 package has not been installed. So I need to go to my directory here, look for the package Table 1. And then I want to install it manually by typing on the install packages directly here. So I can see it has installed, successfully installed. So now I should be able to run the command. So let me see. I don't know whether it is. Let me just rerun it again. So we can write Table 1. Then our data set is called synthetic. I want you to run the frequency for age cut. So running the frequency of age cut. sorry, we need to write a wave. Then we write factor. Then so it's still bringing me an error. Let me see. What if I just run table without okay, so that has not been done. So I go back to load the library. Let me load the library table 1. Then see, please make sure that your table 1 is running. I don't know why mine is misbehaving. Subscript. Who has been able to run table 1? I can see
Able to run it.
sorry?
I was able to run it.
Yeah, I'm trying to load mine. It's asking me to restart my R, which I don't want to do.
Sir, if you restart your R, what will happen? I thought
Nothing.
nothing will. I mean, you will still
Nothing.
have your stuff.
Nothing will happen. So let me just close it. Nothing happens when a package misbehaves. You can actually install it. So let me see. So I'll just let me see. Let me redo the EdCart thing. So EdCart, we created EdCart. Let me just redo it. Just redo it. So let me just run my libraries. Library I need is the dplayer. I'll just run the library dplayer, and then I need to attach my data set for ensuring that view synthetic. I need to run the making changes to the employment variable, which is doing well. I need to make changes to employment T1, which are running very well. Any of this age is running very well. I need to check this one for EdCart, whether it's running. Let me see. Table 1 is running very well. Then I need to check table 1. If table 1 is running very well. But now when I run table 1, yes, now restarting has worked very well. So I go on down here. All these are just frequencies. I want to check any place where
So we cannot see your screen, sir. You are not projecting.
Oh, sorry. Can you see now?
Yes, very clear.
Yeah, I'm saying that my table 1 is now running on the right here. I'm also checking any place where we were labeling. So I see a place where we did a labeling. I want to run it. I'm looking at my right-hand side. I'm seeing my data set is having the young people here. What is the percentage of young people? according to your output. Anybody? If you run age cut, 18.9%. Also, I want you to now, we created we created a data
How
set
come
here.
there's a difference? Mine was 20.7.
This was 20.7.
Yes.
How many young people did you have out of 10,000?
2067.
And mid adults?
I had 4,570.
Yeah, I think maybe your cutoffs are different. So check your cutoff. Yeah.
It's the same cutoff.
No,
Anyway,
that's by the way. It shouldn't be, but you can check. Yeah, you will check, but I know less than or equal to means different things. So you may check where you have a less than or equal to if it is correct.
Okay.
But for now, we are just going to. Yesterday, there's something we did, which I think I deleted. We created a data set with a short name, and we call it what? We call it deep missing.
Yes.
Yeah, and we assigned it to synthetic data set. So this is a command of creating a new data set because we were feeling the name is too long. So you just write DEP missing, depression missing, and then you rename it. So we run this. What we expect to see on our global environment is a new data set with the same number of observations, 10,024
variables.
Good. So can we make sure majority of us are there? And continue to run. Now, once you have this data set on your global environment, the rest of the things we were doing it on the depression data set, the short name. So you can run any code that is creating a new variable. Like here, we created a variable called stress time 1 num. We created this variable and we assigned stressed to be 1, and those who are not stressed, we assigned it to 0. So you run that again, and then we went ahead and labeled. We labeled it, so run that again, stressed. And I want you to run table 1 for stress T1 underscore num and check that you have an output. So we have a variable well labeled called stress. We have age cut, we have employment, we have age. The rest of the things we were doing here. And then yesterday, we also did a box plot, and we wrote box plots for the variable age. Can you run that box plot and see? So I think put a hashtag and write generating a box plot. A box plot is a visualization tool.
Excuse me, Daktari, I don't know if we reached at that point. I think we stopped at the labeling stress now.
Yes, we didn't do
We
that.
we didn't draw the box plot.
Oh, we didn't do this.
Yeah, we didn't do it. It's actually new.
Yes, you did it. Labeling stress. Yeah.
We stopped at leveling stress norm.
Okay. But yeah, I mean, yeah, so I mean, for purpose of learning, you can We can also try a few things. Maybe let's just do a box plot and see. So just type a box plot, and I want you to do a box plot of the variable called age. So you just write a box plot of age, the original age, which is a continuous variable. Just run that and see what you get. So you put your cursor on it and then just run. Where's mine? So tell me what you see.
There is a box plot.
There's a box plot.
Yes, you have a box plot.
Yeah. So that box plot, as you can see, do you like the color?
Oh, it's done.
It's quite dull. So we put a comma and then we say COL, color, COL, and then we put any color we want in quotes. So which color do you like? We can put which color is like but good. Yellow. You can type yellow. So the comma here is to have additional information. So just run that. Try different colors. I want to know which colors you've done. If you put yellow, green, blue, pink. So Irene, you have to say where you are left behind. We said that, okay, done orange, good. Any other color? Yellow, purple, blue, I see blue, red, green, pink. Great. What else do you think is lacking on our box plot? If you look at this diagram, what do you think is missing? Is it well labeled, for example?
We are lacking the name, sir.
Sorry? Name. What do we lack?
A name, the name of the box plots.
The title.
The title, isn't it? For example, we are missing the main title of this. And this is a box plot for what?
For age.
Yeah, so we can put another comma and we say main title. I think we can write main. Main title. We can call it box plot of age. Yeah. So we want to see. Can you make sure that there is a title for it by writing main title? Main title, you just write main for main title. Who has succeeded in doing that? Yes, good. Anybody else?
Yeah, it's there.
Good.
Done.
Very good. What else are we missing on this box plot? What other label are we missing? Is it well labeled? Anything we are missing not labeled? Is the x-axis?
Maybe the, yeah,
X
the
and
X
Y.
and the Y.
X-axis.
X. Yeah.
X and Y.
Yes, good
X-axis.
So
The Y
X,
it has a scale.
Yeah, so the x-axis has nothing. I don't know how do we call it? The x-axis, let us call it anything. Usually, if you have a bar graph, you would have an x-axis. For this one, it is just showing the median line and the 25% value and the 75%. Yeah, and then outliers. So for the x here, we have nothing. So we can just label it nothing. Yeah, so the X label, just write X label lab in short. Just say no label or nothing. Of course, you are not expected to write nothing, but you don't have, and then you can label Y label. Just write Y lab label for short, and then just put age of these patients, age of patients. So you have done that, so you can run it again and check that the graph is behaving well. So I want you to also try another hashtag, just try generating a histogram. What do we generate? Let's say a histogram of, you want a histogram of what, age or income?
We can change the variable to something else.
Okay, you want income?
Yes.
Income time 1. So I want you to generate a histogram. And for histogram, you just write hist, and then you put the variable name. You choose a variable you can hit the $sign. You can say income time 1. So I want you to run that histogram. Who knows the work of a histogram? What is this diagram telling us?
It
Should
helps
tell
us
us
know
about
if our
normality.
variable is normally distributed.
Somebody saying it tells us whether the variable is normally distributed. So how do we know that it is normally distributed? That the variable income is normally distributed? If you are to look at this diagram.
There should be a bell-shaped curve, sort of.
There should be a bell-shaped curve. What else?
With mean 0 and standard deviation 1.
Standard deviation of 1. Okay, so yeah, I mean, we are going to look at that, but usually it is usually it just tells us that if it is not a bell-shaped curve, then it tells you that there is something wrong with the data, and the consequence is that when you do that, you are going to be asked now to do something different. So when the data is skewed, you run some statistics we are calling non-parametric tests. Non-parametric tests like median, mean, things like that. For example, first of all, before we move on, I want you to label this diagram. Can you label x-axis? X, so now let's start with the main title. So by default, it is giving us a title, but we don't like that title. So we give it a title by using main. So we say histogram, write a title, histogram of income in
Time
income, income year one or time one or year one, and then label the X label, X axis. You can call it, what is the X, the income. Huh? You can say annual income. I don't know whether this were months or income, but this data was checking depression and stress for patients in maybe, I think maybe 3 years, year one, year two, year three. Annual income, then we label Y, you say Y lab, you label Y axis, and your Y axis is number of patients. Number of patients. So do that, and then you run. It should be able to give you, the labels are there. And you can add comma, column, color. You can still add color. So write color, COL, and put color of your choice. You can put green. And the studio nowadays is very good. When you write green, it gives you the color because people are colorblind. So sometimes you write green and somebody says this is blue. So RStudio has brought this nice way of displaying colors. So you can run that, put the cursor on this row, run. Change the color as you wish. And let me see who has done it. Well done. You can see access done. That's good. Now, so that is just a histogram. Somebody was saying that we can check the mean income. So when you want to check the mean income, just write hashtag mean income in year one. So the average income in year one. So I want you to generate the mean income. The mean can also be called average. So how do you just write the word mean, and then you put the variable income. So we want to see the mean income in year one. So you say income, or T1, that is the mean income in year one. The result is down there, 34,419. Can you try the standard deviation of the same? And you will tell me what standard deviation is. Okay. So you say hashtag standard deviation. R is very enjoyable. You can see R is it's fun. You know, just imagine that I'm just writing the word mean and I put the variable and I run, it gives me mean. I write the variable SD to stand for standard deviation, and I put the variable and it generates me a variable. For example, if I want variance, something called variance, and I just write the word var, and I put the variable income, and I say income time T1, and I want to run variance. Who has found a variance or standard deviation? Let me see anybody who has
Deviation is
done
18827.15.
that's standard deviation, right?
Variance is 354461398.
Mhm. What about median? So let's see. Median income in year one.
So median will be what?
Median, who
Median will be
knows what
median.
median? Median, who knows what median is?
Is it mid?
Median. So
Yes,
median
median.
is the middle number when you arrange this data from the smallest to
Oh,
the
I
largest.
didn't know that you wanted the definition. I thought you wanted to say the command.
Command is median, so you just say median.
Okay.
Median.
So the median is actually the middle number if arranged either in ascending or descending order.
Yes, yes. So if the numbers are odd, for example, if the number is odd, it is the middle number. But sometimes you have an even number. Let's say you have 10 records. So if it is 10 records, then you don't have a middle number. So you take the middle two and you get the average. So our median is 35. What is the median? What is your median?
32,000.
Yeah. And then there is other descriptive statistics. For example, there's one called the range.
Yep.
What is range?
There's a difference between the lowest and the highest value.
Yeah, the difference between the lowest and the. So R, unfortunately, R does not give you the direct answer. R does not give you a direct answer. So, but you can try to see what R does. Just put range and then range of income, range. Just look at the range income in year one and see what it is doing. So it's giving you the minimum and the maximum. Are you able to see? What is the minimum income in year one? Yeah.
500. 5,000.
5,000. But what are we looking for? We said that the range is supposed to be
The difference between the
difference.
two values.
So, yeah, unfortunately, somebody has not developed a package that can calculate for us the difference. Maybe that is a project you can do. You can actually develop a package that can directly give us the difference. R, unfortunately, has not given. So the only way we can get that difference, we can manually, so maybe we look at we start with the maximum. You can write maximum value. So let's generate the maximum value. So maximum value. So just look at the maximum income for time one. And if you run, that's the maximum, and then do the minimum income in year one. And you can see what it does is it gives you those things in individual, and you can actually now say maximum or you can even say you can even say you can subtract. You can subtract, or you can create an object. You can create an object and just say object Y is the difference between the maximum income, and you can put minus minimum income. See? Minimum income in year one. So you can create an object Y to hold the difference. And like we said, an object here is just to hold the answer. But when you want to see what is inside, you just type Y. Just type Y, and it gives you now an answer. So that is how a range can be generated from that. But we also have summary statistics. Summary statistics. Sometimes you just don't want to do them. You just say the word summary. It will give you a summary or summarize. Let's see what summarize does for income. No, not summarize. It's supposed to be summary. Summary. Yeah, summary. So just run summary, and it will give you the minimum, the first quarter, the median, the mean. So the command summary just in one command. So you get the summary statistics. So who can tell us what first quarter is? What does it mean? What is the definition of Q quarter, first quarter? Like when they say in this income in year one, the minimum income was 5,000, then first quarter was 21,000. So what does the first quarter mean? First quartile, actually. The term is first quartile. Yes, I think somebody has said a quarter of the data set is below that value. So a quarter of the patients are earning less than 21,000. And then third quarter means 75% or 3/4, yeah, of the patients are earning 44,000. Up to 44,000. But on average, the patients were earning 34,280. So that one is good. I want us now to try something called correlation analysis. Just few things. Correlation analysis. What is correlation? So we want to say
relationship.
I want us to do it for continuous variables. What is a continuous variable? So when you want to look,
that can take
yes,
all decimal places.
Yeah, a variable that can take a decimal point. So in this data, which are the two variables which we can relate, which can take decimal points?
One of them is income, maybe.
And the other one?
Age.
Look, and age, okay. So we want to try and relate your age and income. By the way, is there a relationship between age and income in real life?
Yes.
There should be.
So what will be the hypothesis? So actually here, let us call this section hypothesis testing. Hypothesis testing. I want us to play around with this. What is hypothesis, by the way? I know this is not a statistics class, but what is hypothesis? What are we testing here?
We
Hypothesis
are
is a
testing an
claim.
assumption. Hypothesis with an assumption made, and then we are trying to prove for or against the assumption.
Yeah, a hypothesis is an assumption of something you think will happen. You are trying to give a prediction of what the result is going to look like. So it's like trying to predict what the result is going to be in advance. So you imagine that I want to think that age is related to income. So there is some correlation between age of somebody and the income. How many types of correlations? How do we interpret correlations? Analysis. What are the 3 things to look for? Interpretation.
The correlation coefficient.
We'll
Yes,
look
so
at the sign, if it
We'll
is
look at-
negative or positive.
Okay, sign of the sign.
Coefficient, the direction, and the magnitude.
So sign means direction, right? Direction. So sign of the correlation, sign direction of coefficient. We will look at the sign of coefficient. Next time we have a statistics class, I will take you through these things. Then sign of correlation coefficient. Then somebody has said the magnitude.
Magnitude.
How big it is. For example, if it is 70 and above, or if it is 0.7 and above, then we say that is very strong. We can also look at the significance of the correlation. I'm putting these things under hashtag because these are just comments, right?
Yes.
So let us run correlation using the correlation. Just write core. And you can see when you write core, the R is giving you options here. You can write core of X and Y if you like. Then you can write method equals to Pearson, or Spearman is equals to C of Spearman, Pearson.
Can I do? Mine is not giving me the options when I type.
You just point at the, if you type COR.
Yes. But it's not effective.
Yeah, just write, let's look at, just put the variable age. Which one predicts what? Does age predict your income, or does your income predict your age?
Age predicts income.
So which one is called the independent variable if age is predicting income?
Age.
Age is the independent.
Dependent. And then our dependent variable is?
Income.
Income.
So we want to start with age. So I want you to correlate age So put age, and then put a comma, and then put income in year 1. Then run. And then you can run and tell me what you see.
0.080.
Okay.
That's the correlation coefficient.
Yeah, 0.0, and yeah, we can add other things. We can add other things. Let us add other things like method. So there are several types of correlation coefficients. There are others, you know. For example, there's one called Pearson. So if you write, you can put a vector C, and then, so put a vector C, and then inside the vector, put something like Pearson, or let's say Pearson. I will tell you what Pearson is. You can put Pearson and Spearman, just those two. I will tell you what those things mean if you are not a statistician. So just add those ones. What are we missing?
So you should have another bracket.
Another bracket. So we have how many brackets are here?
It should be 2. 2 to open, 2 to close.
2 to open. Really?
2 brackets. One by the C and the other one by the correlation. It's okay, I think.
Is yours running?
Last
It's not
method,
running?
it will go, which is the
Sorry?
Kendall.
Sorry?
There's one that if we include the Kendall method inside the method, it will run.
So you want us to include Kendall there?
Yes.
Why should it tell us what to want? There is still something here. So there's still something here. Who has seen where the trouble is? One method at a time. Let's see. What is saying one method? Okay, one method at a time works. So let's do what someone is saying. Spearman. And then yeah, so let's just do the 2. So when you look at the 2, the first one is called Spearman. So we can put a hashtag here and say assuming normal distribution. So Spearman is a coefficient which you only report Pearson if your data is normal distribution. And we have said the normal distribution is where your mean and your median are almost close to each other. But this one called Spearman, you assume non-normal or skewed data. So when your data looks skewed, like now our income is slightly skewed. There are a lot of people who are earning 5,000, and then there are a few people who are earning 150,000. I don't know whether this $150,000 in a year. So that means that our income is a bit skewed. So rather than reporting the first one, Pearson, we will report that the coefficient is 0.078. So who can help us interpret that? A coefficient which is more than 0.7 is very strong. One which is maybe between 0.5 and 0.7 is moderate. But the ones which fall below 0.5 or less than 50%, those ones are weak. So the correlation is said to be weak. So I want you to also repeat this, but just call it correlation.test. Test now. Those are also doing two different things. And you can either use one of them. But this time, if you say correlation test, it generates confidence intervals. It generates for you confidence intervals. So you can see that there's something called confidence interval here. So it generates for you confidence interval. And then what else are you seeing in the output in the console? So I would recommend the correlation test because it gives you more statistics. See, it tells you that the correlation coefficient is 0.08. It is what they are calling sample estimate. Then they are telling you that 0.08 ranges from 0.06 to 0.09, meaning that you are 95% confident that in a true population, the average coefficient will be range from 0.06 to 0.09. This is a very weak correlation because, and then it gives you some other statistics. This one here is a very small number, 1.07 times 10 raised to power negative 15. That result means it is smaller than 0.05. So that result is statistically significant. What it means that the correlation between income and age are statistically significant. That means they are strongly correlated. Sorry, they are significantly correlated, but the correlation, however, the correlation is positive but weak. So it has got a very uncertain result from there. So who knows how we can test whether variables are normally distributed. So let's say testing for normal distribution. So can we check that the two variables are normally distributed. Who knows the test?
We can use Shapiro test.
Shapiro.
We can also use Cosmogorov.
Shapiro-Wilk.
Shapiro-Wilk or Cosmogorov.
So let us make it easy for non-statisticians here. Let us just call it Shapiro-Wilk. So for the people who are here, just write the word Shapiro .test and then put the data, put the variable age. Shapiro-Wilk test is telling us whether the data is skewed or the data is normal distribution. So, and it helps us to decide which statistics to use. So when the data is skewed, as I've said, the tests that we do are different from if it is normal, unless of course you normalize. So test the normal distribution for age and income. Of course, that is what you do first before you even decide whether you are reporting Pearson or you are reporting Spearman. So Shapiro-Wilk test, please run. The test is not there, must be between. Or the sample size is too big. The sample size is too big. So we want to be able to run this. So this one is not going to work. But if you were to run the tests, I can tell you here, we will declare normal distribution. Who knows how to declare the normal distribution? No one. Eh? So we will declare that the data is normally distributed. So data normal distribution.
Sir,
yeah,
we can use Kolmogorov's Smirnov test since he's asking that the sample must be between 3,000 to 5,000. So Kolmogorov can go beyond that.
So give us the code. So let's change this. Give us the code.
KS.test.
ES.
KS.
Let me just change this. So it's KS dot test.
Then we write we insert the data.
Okay, so let's run that. Why is missing with no default? Okay, what is missing? So let me see. So some of these things you will have to get online. These complicated tests. X is missing with the no default. Okay.
Yeah, I removed the
my
comma.
friend.
There's a comma before the first step missing edge. Yeah.
This one.
Yes, remove that.
P-value will be approximate in the absence of ties. So what does that mean? But anyway, that's produced for us a result. The result here is, so let's The result here is, so let me just put for you the hashtag. This is another statistics for people who are interested in more interesting statistics. The output here is saying the p-value is also very small. That means it is significant result. Again, it follows what we were seeing with the Spearman correlation analysis. I wanted us to try something else. Let us try to do some visualizations. Visualizations are just plotting maybe a graph. Some few more graphs. We have tried to do histogram. So let's try some new graphs, but for us now, we have to install other packages, like there's one called ggplot2. ggplot2 is a very nice package for plotting graphs. There's another one called, another one I saw called, yeah, this one. These two packages are good for plotting graphs. Can you unmute me? Sorry, Benjamin. Okay. How do I mute Benjamin? Let me see. Benjamin. Okay, Benjamin, you can speak. Benjamin can speak.
Can you hear me?
Yes.
I haven't been following. From the beginning of the class, I've been typing that I should be unmuted.
What?
I haven't been following since the beginning of the class. I only succeeded to import my data. Since then, I haven't.
So once, so Benjamin,
Can you hear me?
What I'm saying, once you imported the data, the only thing you need to do is to create this short name for the data set. Benjamin, are you there? Benjamin? Benjamin, I can't hear you.
Can you hear me, sir?
What I'm saying, once you imported the data, how many data sets do you have?
I imported.
What is the name? Synthetic data. So I said that we created a shorter name.
Synthetic data.
Yes, but we said we created a new name where we said just write DEP missing. Have you done that? And then assign to synthetic data. That's what we did first. Did you do it? Benjamin.
I can hear you, sir.
Have you done that?
I'm doing it.
You do that, and then you run the package. Then you, even once you do that, then just pick up from where we are. Whatever code we are writing, that's what you write. You don't have to write everything that we wrote earlier when you are not there. When you come,
Yeah,
and
error. It's error.
Why? What is the error?
Depth missing.
No, but you run it again. Did you run the package called, did you run the package called, sorry?
Yes, I have the package.
Can you run that and create a new data set? Okay, Benjamin.
Sir?
Benjamin,
Yes,
can you run what we are doing using your old data set? So when we are writing deep missing, you'll be writing the data set synthetic depression missing because you have the data set. So you can still use synthetic depression missing data and you follow. When we write DP missing, you write synthetic data, it will give you the same results.
Okay, it's going now.
So for now, Benjamin, can you install these two packages? We are starting here.
Okay.
Can you install these two packages? And all of us, and then let's run the library. There is somebody here who is making a lot of noise. Benjamin, is that you?
I'm doing that. I'm installing the package.
Okay. So all of us, let's then load the library. These are the loading library for graphs. So how do we load the library? We write library. And then you write ggplot2. Then you also run library of gg pub r. So please install the two packages. These packages are very good with graphs. They make the graph more nice. They make the graph look more interesting. And then load the library and let me know who has done it. ggpar, I can, if it is not installing, I will go to the window or directory, packages, install, and I will write ggpbur. I will force it manually to install. We'll get a warning that restarting R, but eventually it will install. So if there's a package that is refusing to install through a command, you can go to the directory or the packages and click install. Many times, it just installs things. Who has installed, loaded the two libraries? I think Dan, Martin is done. Who else? Yeah, I see people down here. Very good. So now that we have those two packages, it's sometimes, so let us try to run some graphs. Let us try to plot, let's say, a graph of age. Let's just see how we can plot a graph of age. Or what did I plot here? Let us just try to plot, type plot. No, type something like . So there's ggqqplot, plot, and then let's put the variable age. So in R has so many packages, and some people use the packages that they like. Yes, Nora, you install the package ggplot2 and ggpubr, and then you load. Okay. So can you try to do this? Not function. Sorry?
It brought out a very nice graph.
Has brought you a very nice graph. Huh?
Yeah.
Mine is still misbehaving. Let me try it again.
Hello,
So it's not
Vincent.
finding that particular this particular package.
But it is giving you a graph.
ggqqp plot. No, for you, I'm looking at it gave me a graph already.
Which command did you
error
use?
message and the
Which
same.
command did you? The same.
I used the ggqqplot. Plot.
Okay. Anybody else whose variable has run?
Hello, Vincent. I got late joining and I understand statistics, but could I get your recording so I can follow up slowly way later?
All these sessions are recorded. So if you go and you see Joel is putting them on your, even I saw yesterday's recording, they're on YouTube, they're on, so they put it, Joel is here, Joel?
Yeah, cool. Joel, please take maybe my email so he can share the link, or where will we find them?
I'll put the link on the chat.
Okay.
Okay.
Joel, I've been messaging you to add me to the WhatsApp group, or you have not been responding.
Joel, please address the WhatsApp issue.
So I think to just make a suggestion, Joel, the best thing is, since you have our emails, if you can put that link in our emails, is better.
Exactly.
Joel?
Okay, sure. We will share on email.
Because I told you yesterday your one is full.
Yeah, the WhatsApp group is full. We are considering having another one, but we will
Just share by emails.
Okay.
Just share by emails and label the days, day 1, day 2, day 3, so that everybody can have access to it.
You can also share in the group, in the chat, so that it can just pin on, put somewhere.
Okay, Joel, I have posted my email in the chat box. Please take notes.
Okay, could we kindly proceed? We will share the links on the WhatsApp and on
I am not in the WhatsApp
chat.
group.
I said I'll share the link on the chat.
Okay.
Doc,
Mm-hmm.
Doc, I'm sorry. I also joined a little bit late, and I'm catching up. I only have a problem with the histogram, so I'm requesting for your 3 minutes after when we go for break. If I can have you back for 3 minutes, we talk about the histogram. Thank you.
Who is this, Abigail?
No, this is Irene Okanda.
Irene, what is the problem with histogram? We can just say it now.
I'm saying I joined late, and when I
Okay.
was trying, yeah, so I did catch up with the histogram thing. Right now I'm at par with you, but the histogram part, I didn't get it.
Actually,
So,
we are plotting graphs. So if you write hist here, just write hist, HIST, and then put the variable name. For example, just put age. That's what we did. So if you run that, you get a histogram. So Irene, just do it and let me know.
Okay, Doc. I have a problem with the ggplot. I've tried to run it in my R script window, but there is an error that it keeps on popping, and I have posted it here on the.
What is it saying? What is the error saying?
The error says RTools is required to build R packages, but it's not currently installed. Please download and
Yeah, so sometimes you have to do what the package is saying. So if it's telling you to do something, you can sometimes just do it, because it depends on what you have been able to set up to prepare R. So if it's telling you to install something, just try to install. So mine is not running, so I will use another command. I want to try, just write gplot. And then I write version. Sometimes these things can, because of the many packages we're using. Okay, I don't know why my functions are failing. Let me see. Let me just try to install them again. Even ggplot didn't run, so let me just install it. ggplot. Who was able to get a graph?
I did.
Who else?
I also did.
So I'm the only one. They didn't get it. Anybody else?
Hello, I'm also not getting, I'm getting the same error like yours.
Probably I'm trying to reinstall the ggplot package directly, manually from the packages here. Because
Doc, just a concern. Is it gplot or ggplot? Because yours is gplot.
So there are so many packages. You see, even if I write ggplot here, there is ggplot. Let me see. There are so many commands which work with different packages. Let me see. Even this one is a different code from this one. You see, it cannot find ggplot. So I was trying gplot. I think there's something wrong with my R. I will try to update it. But just try to run one of these. Let me just try to run one of these. Whichever one runs for you. There's ggplot.
Doc.
Then, yeah.
Yeah, I think it's the same problem you are having. So maybe we need to figure out.
Yeah, not find the function ggplot. Will not find the function ggplot. Okay. So I'll I'll try to update my R. I'm just going to try and update my R, see if I can. So I've just gone to packages, and then I've clicked update. So I want to update my R, and I've said select all. So I want to make sure that my R is fully updated. So let's spend a few minutes to update our R. And we can take another. Can we take a short break as people update their R?
Yes, Vincent. I think this is a great.
Yeah, let's take 15 minutes break as people update. Let's come 15 minutes. Let's come back at 3 p.m. That's almost 22 minutes. I want everybody to be on the same because today is our last day. And please just make sure you can plot a graph. Or you can go to packages and say update during this break. If you have a question, just please proceed and answer. The rest, let's take a break.
Oh, well
Thank
done.
you, Vincent.
Well done.
So yeah, thank you. One person at a time. You can ask question, take a break. Then we come back at the top of the hour.
My name is Rose.
So yeah, so welcome back. We were just finding that the way we have this, the way we have our data set, the data set is too big, and we may not be able to adequately do what we want to do. So what I want us to do, just for the purpose of looking at a simple bar graph, so let's just say, let's just create hashtag, let's just create a simple bar graph. So let's just create dummy data because this data is too big for what we want to do. So let's just create a variable. Let's just create an object with some numbers. Let's say, let's just create simple things, maybe 20 or something. Just put some numbers here. Just create a small object just for us to show a simple thing. Maybe we can put, let's put some months. For example, let's say, let's put months. Let's say January, maybe February, March, something like March. Let's just write simple things so that our bar graph is manageable. Maybe June, March, April, maybe April. 1, 2, 3, 4, 5, 1, 2, 3, 4. Maybe May. Just do what I'm doing. So we can give this chart a name. We can call it what? We can give it a name. The PNG is just to save something like a photo. So we can give it a name. Let's call it bar chart of something. Maybe let's call it a bar chart of of what? What can this be? Maybe, what can this be? 28. Are you there?
Yes, sir.
I'm saying these things at 7, 12, 20, and we want to plot a bar graph this month.
Bar chart of
Maybe you can say temperature.
or rainfall. Maybe days of rainfall.
Rainfall, amount of rainfall.
No, days.
Dr. Vincent.
Okay, so we say bar chart of days.
Dr. Vincent.
Yeah.
The variable I created, the H. Yes, where your cursor is. Mine is not, is error.
This is just a dummy variable. We are if you write H and you assign to a vector,
yes,
like a container of this, is it giving you an error?
Yes. Yes.
Maybe you're not putting a comma somewhere. Check it out.
All my commas are properly placed.
It's not supposed to give an error.
So I don't know. Let me see mine. Mine is running. Just highlight it again.
Okay, let me check it. Oh, it's okay now.
Yeah, sometimes these things just misbehaves. But
It's
if
okay
you want
now.
to
Thank
see, you'll see under the global environment, you'll see something. So let's just create some dummy things. And now let's plot the graph, plot the bar chart. Our data set is too big, so I don't think it is. Can you now plot? Just write bar plot. And then put the, sorry. Just write bar plot. Bar plot, and then put the variable H. And then put names so that it names the M. And then the label, we can label X. When we label, you can obviously see. Oh, did we give it a name? Sorry. I wanted us to name the file. Name the graph. So let us just call it PNG format. And then let's give it a name. Let's just say bar chart of rainfall days. I don't know whether rainfall can be 41 days, but it's okay. So, so we want to give it a name, but now we plot this. What's in a graph? Then we can save it. What's in a graph?
I'm not seeing any graph at my site. Even though the bar plots is not showing any error.
Not seeing anything. Okay, let us assign it to, let me see. Not showing me a nice graph.
Good.
Sorry? No bar graphs. Okay.
I got the graph.
You got it where?
The graph is there.
Where? Some people are not seeing the graph. So can you help them see it? Who is saying they have seen the graph? Charles? Irene?
I have.
Who is seeing the graph? I see some people are seeing it. Yeah?
I did.
Where is it? Is it on the left or the right?
On the right side.
Yeah.
I'm seeing the
Who
graph
else?
also.
Okay.
I can see the graph also.
I haven't seen the graph. I haven't seen the graph.
Incorrect number of Joan. Check your, you said bar plot h names dot m. Incorrect number of names. So those who are seeing the graph, please add other things. You know, you can now put the title. For example, you can say the X lab. You can give it the, let me run my library. Probably my library is also having an issue. Let me run my library. So who has, again, I want you to label your x-axis, label your y-axis. Who has seen a graph? Please add other functions. Add, you can say main. That helps you to put the main title. Just say bar graph, bar plot of what? Rainfall days. Then you can do a X label. You can label your X, just say X label. X-axis, just call it number of months. We just say month. And then your Y label, just call it maybe days. You can also add other things like border equals to, if you want colors of the border, you can give it another color if you want. Call it maybe red. Things like that. There's an equal sign. Equal sign, let me see. Oh. Argument equals to M.
The border side, there is no equal to at the border side. You're supposed to have an equal to.
Yeah.
You can remove the bracket also.
Yeah, I'm seeing I have a bracket here. No, there's a bracket at the end. Then what else is missing? This should be fine.
Can also add color.
You added color. I'm just, yeah, the color you can add, but yeah, you can also add a color. Or even instead of the border, I can put color. You put your favorite color, maybe blue. So that should give you a graph. That should give you a graph. Mine is not displaying, but I hope yours is displaying.
Yes,
So please, are we doing a different data set?
Yes, we have created a data set here. We've just created a small data set with H and M.
Sorry, I just got back from my own break. Sorry. Okay, let me just follow, and then I can do that later.
Yeah, you can do that later. Yes, so try that. I want to see how many have charts. If you have already plotted, remove month from the bracket. Remove, who is this? Somebody is giving, what is seeing an error? Somebody is seeing the graph, somebody cannot see the graph. Benjamin, I unmuted you, but you went mute again.
No, I'm with you. Can you hear me?
Yes.
Yes, sir, I'm with you, but my graph is not working. I'm still trying to look for where the error is.
Mine is working, except that there are so many brackets. So can you guys just check your brackets? Because now mine is working. Can you see my graph here on the right? Who can see my graph?
I can see it, sir.
Yeah, there was a bracket at month here. Somebody has detected. So remove the bracket around the month. I think that's where my problem was.
Yes.
So even a teacher can miss to see something. That's how you learn.
Mine is not working. I've removed the bracket, but it's not working.
No, just check. Have you saved the file name like PNG file, and then
Yes.
You can write. What about this?
Yes.
Yeah, just check on it carefully because so there's only one graph. There was only one bracket at the beginning and one bracket at the end.
Yes. I don't know.
Who else has now succeeded? I want to see.
If it is my spacing, I don't know.
Argument is not numeric. So Charles, make sure that H, when you write M, names of argument, put the month, the object M. Don't put H, don't start with the M and then H. This H has to be numeric variables.
I just checked the structure of this, my bar plot. It's showing
Martin
me.
has succeeded. So what if I just, for example, because it wasn't going to work, let me just see.
Dr. Vincent.
Yes.
I just checked the structure of this my bar plot, and I'm seeing that it is a function height. Is that, I don't know if that's what the structure of your own is.
My data, I've just created a numeric data with H, call it H. And I've just put it as a vector of 7, 12, 28, 34. And then I've created a string variable with the several months. And I've called it M to stand for months. Okay. Then I created a file called, I made sure that ggplot2.
Vincent, my problem is not even the command. It's not yeah, it is giving blue. There's no error, but the graph is not generating. It's just remaining gray.
Same here. Same here. No error, but the graph is not generating.
Somebody is saying it's blank or gray.
No, there's no error. There's no error.
Mm-hmm.
Every variable seems to be okay, but the graph is not generating.
Can you post your? Can you post your?
Okay,
let
me paste it.
Yeah, can you just paste it? So guys, all these 4 commands, we have written them at the same time. We have run the library ggplot. We have created a data set called H, and then we put another one, and then we have just created a file name for it, so that the PNG is just a picture, and then we have plotted the graph here. You pasted it, so let's see. Names equals to M main per plot of rainfall days, X lab is months. Y lab is days, color is blue. So can you run the ggplot library again? Can you load the library again? And
you mean the ggplot2? The ggplot2?
Yeah, run. Yeah. So you run, or can you run it again? All these files.
All of them.
So for those who have done it, so that we also save time, let us create another row and let's now try to plot a pie chart. Let's try a pie chart and the procedure is just the same.
Doc, sorry, I wanted to know more on the bar chart. For example, if we wanted to plot for more variable like gender, marital status, and maybe educational status.
On the same bar?
Oh yeah, on X, yeah, and on the Y, maybe if we will put the pressure.
So those are complicated graphs. Some are called charts, some are called stacked graphs. So I'm going to give you a command that maybe you can play around with, but for you to fit, like now January, you want to say January male, female, February male, female, then you need we have to do a more complicated coding. But something I wanted to show you, and I'll give you a code. Something I wanted us to copy, want people to look at this code here. There's another code here that is always also used. It's a long code, but people have said it is more efficient. For example, I want you to try and put the data set name here. Just try it. Then let's see, X, can put sex, yes. And then we can try income, T1, sex. We can put identity. Can you try this code? This code is a long code, but it's said to be a more efficient code. So you run a GG, make sure your library is working. And then you can run this command. We have a very bad, I don't know whether income is the best. Maybe we try age. It's weird. Or we can put here age cut and income, or maybe we'll try income. Looking a very bad graph. Oh, it's working. Actually, I can keep it. Sex and income is working, but it's just that income is looking very bad. So can you run it? Who has run this? It's a nice code. You just create a dummy, just create an object called bar1, then say ggplot, and then put the dataset name, data equals to the dataset name. And then there is something called aesthetics, AES, aesthetics. That means you want to create bar graphs that has an aesthetics. Those are just colors. On the x-axis, you want to see sex. On the y-axis, you want to see age or income. or income. And then on the filling, you want to count the number of people with the X. This is a geometric bar, and so the statistics is set as identity. That means that the number of values will be default. And then we just say annotate sex as text. These are just restricting the sizes of bar graphs. X, you can restrict to anything, 0.6 inches, 100. Those are just units of measuring height. And then label, you don't want a label. And then the title of the graph, you call it GG title. You can put at GG title. So can you try this command? Whether you put income, it doesn't matter. Will just come.
Hello,
And
Vincent.
then
Dr.
for you,
Vincent, this depression data, depression missing. Do we have it? Is it part of the thing we are supposed to upload?
it is there because we copied it. If you don't have it, just use the depression missing data.
Okay.
If you don't have depression missing, use synthetic data. I mean, it's just the same data set.
Okay.
So can anybody see a graph?
So your income in the code 297, your income is saying income TI instead of income T1. Maybe that's why it's not running.
No, mine is running. I have it here. So let me run it again. I just need to, let me remove this graph. But you see it's running again. I can, yeah. Just rerun it, you'll be able to get. Just refresh.
So please, can you move the, so that we can see the code very well?
So while here, you can call it this income. I want to see anybody who has seen a graph. And for some of you who are not happy, seeing like people like Joan, can you try to plot a pie chart? Probably it will look nice. So Joan, I need to unmute Joan so that we have two Joans. I don't know who Joan is. Joan Mutahi.
No, I am here.
Uh-huh.
And
are you seeing,
I have
you
no
seeing, you have no error?
I have no errors, but no graphs at all. Nothing.
Okay, can you try a pie chart? Joan?
Yes, I can.
Can you try pie chart? Can you try a pie chart of put the data set name, and then you can put labels. Just put labels. For labels, you can use M, I think, because M was our, no, we need to create, no, let's create labels. So let's create. Or we just say, let me see the error. So for labels, I think we just say, we can make it simple. So let's see. We can make it simple. Just say a pie chart of a H, a pie chart of H, and then we have labels. Just say labels is equals to M, because M is our, and then we can put a title. We can put the main title.
2 equal
the pie
signs.
chart. Sorry? Oh, no. Just put 1 equal sign. Then the main title, we can call it something. Pie chart of what? Rainfall days. Rainfall days. Pie chart of rainfall days. Pie chart of rainfall days. Pie chart of rainfall days. So just run that.
No error, still no plot, no chart.
Let me see mine. I need to clear this. Let me just run mine. Mine is there.
Yeah, like today I'm having none of this.
Can you run the library? Can you run your library again? That ggplot too. Just with R, sometimes you just highlight it and run it.
I have run it and the library has run. DevOff was running, but then was also telling me like if I run DevOff, then I would get PNG2 below it when I run it. So everything is running, but the charts is where
the problem is.
Yes.
Okay, I will give you time after. Who else is seeing any pie chart? Pie chart. So Johan
I'm able to do a
Mulay
pie chart, but
Mulay
I
is
can't
giving
do this
you.
other one.
Which other one?
This one with a long code. The power one using the ggplot.
Yeah.
It's giving me an error.
Let's just use simple one for the time being. Patrick has got a pie chart. So Irene, they are saying you need to run the variable. You need to run H and I don't know, but try to run your H and M. I have a pie chart, but not a bar graph, which is fine. Anybody else with a pie chart?
So Doc, my M has refused to run totally. What happened?
Your M has refused.
Yes.
Okay.
So I've realized like if you cannot run the H, like the M and H concurrently, if one of them has refused to work.
Yeah, so just abandon, just follow, just go and do a pie chart. Have you done a pie chart?
Yeah, I've tried with a pie chart also, but I think it's similar thing because now M need to run.
Do you see M in your global environment? For example, in your global environment.
I don't.
So you are M as you have not assigned M to anything. The months. Have you run the one where you say M equals to C?
Yeah,
and then
that's what I did. I tried to assign now M to month, but now it has refused. It says like the argument of 6 is empty.
H is there,
Mm.
but I can't see the M.
so maybe we'll get time. So I want us to, we
I
will
got
get time.
both. I got both, but my dev.off did not run.
Sorry.
I got both the bar chart and the pie chart. I was able to run and it worked, but the code before the plotting of the graph, that's the dev.off. That one didn't work. I didn't see anything, no output. I don't know if
So
you can
some
hear
of
me.
the some of these questions, let's preserve them for. I can always reach out. We can have a makeup because I'm
All right,
worried
thank
that
you.
we are having time is running and we have not finished some things here. So I want us to add percentages. So let us create a formula for adding percentages to the graph, to the pie. We want to create a formula of percentages. And how do we do that? We just say H divide by, because getting a percentage is not easy. The sum of M, not the sum of M, maybe the sum of H we want percent, so percent should be times 100. Just the total, we take each of them, like every H, we divide by the total number of all of them to give us a percent. So just run a percent. N not found. No, I'm not saying M, but H. So run that. That is just an object with percentages. And then we can now go back and use that percent to paste it. So can you paste that percent into the months? Just create something like M. And then we can now add the labels. So we just say, after we paste, we can just assign the months. Each of the months we can paste. Sorry. Paste the M's. And then we need to do something here. We need to say, there's a global command here, which is, and then separate it with the quotes. So this one is doing something. Maybe you remove the, so can you do that and see what you get? And then now rerun the pie. Of M, then labels equals to your M. And then you can say color equals rainbow. By the way, there's a color called rainbow. So then the length of the it is supposed to be pi labels unexpected. That is fine. Then it's supposed to be pi. Just check your code. I'm trying to sort out my code. So mine is unexpected comma. Comma color equals rainbow. Okay. Pie chart of rainfall days. Unexpected opening bracket. Wow. So can you now run that? We are just trying to have the bar graph. So the pie chart have percentages. So we create that percentages, we did that. Then we pasted, then here we are using a global symbol here to make sure that all the percentages are held and it is pasted on the months. We rerun the code for pie chart again, where now we run, M was the months, and the labels now for months is going to have percentages. We have chosen to use a rainbow color. Rainbow means that it will pick, the rainbow is the colors of the rainbow, the VBR, VBGOR, ROIGBIF, and then the length of the length, it should just paste the percentages within the months. So this is a code we want to see if you can run it. Values must be positive. X must be positive. So what? X. My X has refused. Let me see. X. Oh, it should be H. It should be H, sorry. I have a beautiful pie chart. And you can export it by copy pasting. You can copy it. You can save it as a PDF. You can copy, you can save it as an image. So let me see anybody who has a nice pie chart. That will make up for the disappointment of bar graph. Who has seen anything?
Yes, I got it.
Yes, I got it.
Beautiful. I just want people who are happy. Who is sad? You know, colors. Who has seen anything? May, Johan? Johan? Johan is 0. Johan. You may want to just be patient a bit. I see people are seeing everything. Some people are seeing Irene Okanda. At least Irene, you are there. Who else? Joan, just reach out. I will help you. I'm sad. Amos is sad. Amos, just check the objects. Remember, we have created a H. Amos, we have created a H. We have created M. M is the months, but H are the days. And then we said we want to add percentages. So I wanted to know, Amos, were you able to see a pie chart earlier? Let me hear from Amos. Amos, can you unmute? Amos?
Okay, thank you, Doc. No, I was not able, I was only able to plot the bar chart.
No, the pie, when we started pie chart here.
I don't know, I was not able.
Did you create a vector of numbers, H and M?
No, I think I missed that somehow.
You missed it from here where we were creating. We created two things. We created, do you see my screen? Did you do this?
Yeah, I can see.
Yeah, you are to do this first.
Okay.
You are to run ggplot2 and you are to create a vector of H and M. That is where we started.
Okay.
Yeah. So Joan, unexpected break. So Joan, I can see your error. Here you need to have a space. So Joan, you say paste in bracket M and then this percent sign. And so Joan, where's Joan? I want to hear Joan here. Joan, can you speak?
We are two of us. I think the one
there's,
who has...
there's one who was called Mutahi.
That's me.
Oh, it's not you with the problem. So who is where?
No,
There's a
I have
Joan.
a problem. No, both Joans have problems. Like for me, today I have no graphs and no charts, but for her, you're responding to the other Joan now.
Oh, the other Joan, I think, has just put, after the percentages, she has just put PCT. After this percent, she has put PCT. So there are two lines of M's. One is pasting the percentages, and then this one is assigning those percentages to a global variable. So there are two M's. These things are, there are 4 lines of codes here.
Okay, let me correct it.
Yeah, there are 4 lines here that you need to write. 1, 2, 3, 4 to add percentages. So Ekiru Stephen, M is on, yeah, so Kiru, that's fine, but Stephen, I don't see your H. Yeah, good. Juliet has done it. Thank you. Joan Mutai, can you speak up? There is a problem with your...
Telling me I'm passing.
Why are we assigning M twice?
Benjamin, you have a challenge there. Your code is not correct. The first line, we are just creating the months. We want to assign percent. First of all, we created a formula to create a percent. So I just call it PCT. Yes. This is just a command, and I wanted it to round. Rounding means that it will not have decimal points.
Decimal places, yes.
Yeah, then H over sum of H, you know how we create percentages.
I understood that. That's the formula for percentage, yes.
And I can multiply by. So you run that and it should run. So I now have an object with the numbers. Yeah, but now I want those numbers for every month because we have a pie chart of the slices are months. So I want to paste that. I want to paste that percent into the months. Okay. That's what this code has done. So I want to I'm using an object with the same name. month so that it can be an object, another M, but I'm just assigning an object called M, which could be the same thing. And people do that so that they don't make, so then you paste that percentages into the months. That's what this one has done. So, but now you want to make that percent and the months into a global command that can be, this is like something that is available to be used. So anytime that is a label, so anytime I can even plot another graph of months. And if I want to use the same naming, I can reuse it. So that's what this percent symbol is doing. So the only thing I've added here is symbol, and then it's going to separate like between the month and the percentage. It's going to separate it with a space. And then now I rewrite the pie chart code again. So pi, H was the numeric, and then the labels, now I pick what I have, the percentages. And the color is rainbow. Rainbow means it will pick. For pie chart, because you don't know which colors, you can actually just asking to do a rainbow color. Because if you say color is equals to green or blue, then everything will look like the same. So Vin is asking Charles to close the bracket. Thanks, Vin.
Okay, thank you so much, though.
Okay. Yeah, guys, I think we can just say we have some plots. Some of you will see it. Some of you will have to, we will look for another time. So because of time, I want us to go to the next activity. I want us to go to the next activity, which is now fitting tables, fitting data sets, or let us just call it regression analysis. And remember, in your folders that I've given you, I have given you some, there is a code here in the files I've given you, which is called, in the tutorials that I've given you, when you have time, I want us to run one of the regressions here. Maybe not Poisson. I want us to run a simple one, like for example, linear regressions.
No, before linear regression, can I take you back the question on correlation? When you asked about the dependent and independent variable. So when we are writing the code, are we supposed to start with the independent, or we can start with the dependent, then independent?
No, for correlation, it doesn't matter.
Okay.
Because you are not predicting anything. You see. So whether you start with age and then income, or you start with income or age, the correlation coefficient will be the same. So it doesn't matter whichever order for correlation analysis. But for linear regression, remember, guys, that linear regression is written as y is equals to, in high school, we are saying y is equals to mx plus c. But later on, it is y is equals to a those who know maths, plus bx. Who knows about this? So now you see y is the dependent variable. So y is the outcome that we are assessing. If you want to predict income, for example, income will be our dependent variable. That is what is changing. And if you change age and then age is x, age is the Independent variable is the variable that does not change. It is the one that you are using to modify the outcome. So it's called, for example, we have here age. So we are saying we want to use age to predict income. We want to check, does a change in age affect the change in income? So, and then B, who can tell us what B is? This B here, or M. Any person who knows what it is?
The intercept.
No, the intercept is A.
The slope.
B is the coefficient of
the slope, the
X
slope or
value.
the coefficient.
Yeah, so X is the slope. Some people call it the gradient. It has several names. Others call it the marginal, the effect, the marginal effect. So even if you're doing any other regression, one of the most important parameter here is the one that is attached to the independent, this B, because it is this B that is going to tell us many things. We are going to look at its sign, whether it is positive or negative. And if it is positive, if B is positive, it will tell us that if you increase age, income is increasing. If it is negative, it means if you increase one X, Y is going down, or and vice versa. That is, so the B is very important when you are running any regression. Sometimes we look at the 95% confidence for it, and then we will look at the p-value, and we are targeting p-value less than 0.05. So what is a linear regression? So let us start with the linear regression. Linear regression. So a linear regression is a mathematical equation, mathematical formula. The word mathematical equation or a mathematical formula is a model, Some people call it model. That shows the prediction or the relationship or the effect, the relationship prediction of an independent, prediction of an independent variable on dependent variable. In other words, linear regression is trying to establish linear relationships. Linear relationships. Yeah. So we are very keen on the sign of Y, whether it is negative or it's positive. And we are also very keen, the hypothesis of a linear regression is that X does not predict Y, or X does not have an effect of Y, or X is not a determinant of Y. So those are the hypotheses. So how do we do linear regression? So in your do file here, in your tutorial here, you can see it is also called ordinary differential equation. And you can see I have put here LM. See? So let us go back. So let us say linear regression. So linear regression So for regressions, you can you also create an object. You can call it anything. You can call it model 1. You can call it, you can give it a name. So model 1, model _1. Depends on how you like it. It's an object. Then for linear regression, we write LM. We write LM. LM means linear model. And then we put Y. We start with Y. So our Y is, so we can write, that is why I wanted you to make sure you attach the data. Please attach the data. Sometimes it saves you a lot. So we just write Y, and our Y is what? Who knows the dependent variable?
Income.
In dependent, oh yeah, income. Or I can just write it without the table name, income. But now we write the wave. That wave is the equal sign. So Y depends on X. So we need to write X. X is what? Age. So once you attach, things become more easy. Then data is equals to, you specify the data. So then you run. Once you run, you'll not see anything. When you run a model for the first time, it's just executing this. But if you want to see, you can now type the word model 1_1 so that you see what it looks like. You'll just produce only one thing, but it's not a very good output. So can somebody run that? But the best thing to do, instead of just writing a model, write summary. Summary of the model 1. I think it should give us a better. Yeah, write summary instead of just putting a model.
So please, can you go back a little bit? I had a network glitch and I missed out on when you, after you attach this data, what was the next thing?
You look at my screen. I created an object. I call it something, model 1 or model _. I call it the model or a linear model. Then I assign it to LM. LM stands for linear model or linear regression. I'm just trying to write Y is equals to MX plus, sorry, Y is equals to A plus BX. So the first one here is the dependent variable, what we are predicting. And I have a wave, a symbol for a wave, meaning that Y is dependent on age. And then you write the name of the data that you're using. So do that and then write a summary. And I want anyone who has received a result of summary of the model to just confirm who has seen the linear regression model. Charles? Very good. So you have basically done, you have fitted up, that is called fitting a model into, you have just fitted a model. I am seeing some other things here which we can add. Like there is this, there is a variable called MHLM. MH score. Can you add this variable MH score T1 if it can work? So this one we have run because it has only one variable, one independent variable. So it has only one independent variable. So we call it univariable linear regression. Don't call it univariate. Univariate is a very old name and it's even confusing statisticians. Just say univariable because we have one variable predicting Y. And then what if we now want to do more than one predictors or more than one independent variables? How many factors can influence income? So you copy the same, you just say, now you can put model 2, so that model 2 is a multivariable. This one you can call multivariable linear regression. It means that you have more than one factor predicting your income. So you look through your data and you ask yourself, what else can predict someone's income? I want to put that thing called mental health score. For example, that mental health score is an indicator that you are sick. It is an indicator that you are depressed. Do you think that the score has an effect on income in real life? Hello?
Maybe on the other side, the income may affect the mental health score because probably if someone is earning less, they are more likely to be anxious.
But for the purpose of learning, can we just say that a higher score for depression can affect your income?
Yeah, sure, we can do that.
Yeah. So let us just say that your age and your depression levels can affect your income. So we are going to ask the question, does a combination of age and depression levels affect your income? So we have more than one independent variable predicting an outcome. So we call that one multivariable linear regression. So we do the same. We write LM, which is linear. Then we put income was our dependent variable. And then our independent variable, put the wave, the age. But now we write a plus. And then we write mental health score. Mental score. Yeah, so that one is a linear model. So I want you to run that. And then write a summary. Now write summary. Do a summary of the model 2. Summary of model 2. And then look at the output now. And I want us to talk slightly about the statistics. You can see how fitting a model is very easy in R. It's just LM. And there's a document I gave you called cheat sheet, R cheat sheet. It's very easy. It gives you, simple codes. But if you go to the internet and you search linear regression using R, it will just tell you that you can use a plus here. So it's age plus. So this is looking at what is the combination of the two. The first one, we only had age. And the question we want to ask, the result we saw. The result we saw was giving us intercept. So from the result, we were seeing the intercept was what? Intercept is A. What was the value of the intercept? 28, 258.16. Did you get that?
Yes,
Hello?
please. Yes.
Yeah, and the estimate for B age was
It's 137.69.
137, yeah, 0.69. So those are the values we got. But for this was for age. But again, there was a p-value associated with age. What was the value? You can see this value
Yes,
here.
0.0001.
Yeah, 15 zeros, 15 zeros before this.
Yeah.
So we can, because it's very small, we can just write p-value. We can just write less than 0.00.
Less than 0.00.
Yeah, because it's too small and we cannot, it's highly significant. So what this means is that we can rewrite that equation where we said y is equal to a plus bx. Our y is income in time 1 can be written as, so for us to predict income, every income we can predict by using a constant, this value here, plus this coefficient here, times the age. See? What it means, that is the model, that is a model, that is now the result. It's saying that for us to predict income, we need to take this value, which is a constant,
multiply by
and
age.
we multiply by, if so 1 year, if you increase 1 year, if you increase the age by 1 year, income is going to increase by $137 per year. But if you want to know the actual income, you will add this constant. So for every 1 year increase in age of a patient, their income was increasing by $137 per year. But the actual income at a particular age, if you want to know the income at 100 years, then you just multiply 137 times 100. Then you add to the constant, and you will be able to predict what is the income of a person who is 50 years, what is the income of a person who is 100 years. And this result is saying that the older someone was, the higher the income. And we are able, because the coefficient here is positive, it means that the older they were, the higher the. So now this estimate, this coefficient here, which is positive and is 178, we call it an adjusted coefficient or effect. An adjusted effect or coefficient. Some people call it crude. But now, sometimes you ask yourself the question, is age the only factor that influences income? The answer is no. Income can depend on other things. So what if we now bring in the pressure, depression? What happens is does the result of age still remain significant? So now when we look at the second result, where we have, so we are the value that we have added, the mental health score that we have added, you can assume, you can make an hypothesis that that thing is called confounder. And a confounder is a variable that interferes with the original result. It can actually affect the initial result. So what happens to age? If age is going to change, if the result of age is going to change, then this thing has either modified the result or it is a confounder of the result. So we can see, we can check, but that is another class called epidemiology, biostatistics. So you can see here that age is, the coefficient is 144, and the p-value is still significant. So essentially income, but now look at income has remained the same because p-value is still significant, the coefficient is still positive. So introducing mental health scores does not affect the effect of age. So it's neither modifier of age, it's neither a confounder of age. So whether you have mental health scores, age is a significant factor affecting income for patients. But now, if you look at the result for mental health scores, the B is negative, negative 143. Do you see the same? Negative 143 cents. Can you see the same? Hello?
Yes, Doc, yes.
You can see that in the next model, we have mental health score. And we have put age. So age is positive, but mental health is negative.
Negative.
So what does this negative mean? What is the relationship between mental health scores and income?
So there is
when one
is so when one is increasing, the other is decreasing. That's what it means.
Who else want to say? I heard somebody struggling to say something.
A higher score of mental health leads to or contributes to a lower income.
Yeah. The higher the mental health score, somebody had given us, this is coming from a questionnaire with scores. The higher the mental health, or the higher the level of mental health score is, I think, is a measure of depression or a measure of stress. So the higher the, just call it higher depression. The higher the mental health score, the lower the income. So a higher mental health score has a negative effect on income. It affects income, and it's a significant factor that affects income. Age is a positive predictor of income. So a positive, an increase in age of a patient was associated with an increase in income of the patient. So a few things to wind up on linear regression is that we model linear regression when we have the outcome, the dependent variable is continuous variable. And you assume that the continuous, so these are the assumptions. Number one is the outcome, the DV is continuous and continuous. I'm just giving you statistics, continuous and normal distribution. Then linear regression is applicable. And the decision to use which regression, whether you want logistic regression, whether you want Poisson regression. So if your dependent variable is continuous and normal, then use linear regression. If your dependent variable is skewed, or let's say is skewed, which regression we use? Who knows? Sometimes you have an outcome that cannot be expressed as decimals and it's not normal. For example, total number of deaths in a family, number of people in a family, number of births. Those kind of data cannot be expressed as a decimal point. So they are count data, but you can still run a regression. Which regression is this?
Poisson.
Excellent. Poisson regression. So if our DV was things like e.g. deaths, births. But there's also another one called a negative binomial. There's also another one called negative binomial. They have different assumptions. So you go and read about it. For the day, we are going to do a bit of basic statistics, or we are going to do epidemiology. We can talk more about this, but Poisson and negative binomial are good for this kind of data. Also, when your dependent variable is categorical, or let's say binary and categorical, let's say your outcome is depression versus no depression. Sometimes your variable is like that and can be coded 1 or 0. Sometimes you have a dependent variable where it is a yes or no. Where are you depressed or are you not depressed? In that case, the model we run is called, which model is that? Who knows?
Logistic.
Binary logistic regression.
Yes, binary logistic. And this binary logistic, or even a logit, it produces, this binary logistic produces, it still produces B's, but now it produces exponential of the B's. That means if your coefficient was negative, if your B for linear regression, or a logit, then the log, it generates a log. And so it will be the exponential value of B. Yeah. So if you are expressing this as negative or positive or marginal change, and we run binary logistic, what it is doing, it is calculating something called exponential, because logistic regression is looking at logs of odds. So it is the log, the odds, the log. Do we all know what odds is, or what odds ratio is? This one is called odds ratio. Do we know what odds ratio is? Who knows what odds ratio is?
Measure of effect.
It's a measure of effect. So it just says, so first it is a ratio of 2 odds. So first of all, you have to define what odds is. Odds is the probability of event occurring divided by the probability that event will not occur. So the probability that Manchester will win the Premier League, what is the probability?
One over 2. They either win or no win.
No, let's be fair to Manu, but just give it a value between 0 and 1. So it's 0.5.
0.5.
So 0.7 is being optimistic, isn't it?
Yes, because the question is, what is the probability that Manchester will win the Premier League? We will win the Premier League, whether it will be 20 years from now or now.
No, in the current season, the current season.
Okay.
That will be 0.2.
0.2. Okay. Someone is very pessimistic, so saying 0.2. So if the probability of Manchester winning the league is 0.2. What is the probability that they will not win?
Zero 0.8.
0.8.
0.8. So what we mean by odds, so those of you who are betting, odds is the probability of winning divided by probability of losing. So the odds is 0.2 divided by 0.8. What is the answer? The odds of Manchester winning. So what is the odds?
0.25.
0.25. Yeah. So the odds of Manchester winning is 0.2. Now, when you are having odds of two things and you get a ratio of the two, we call it odds ratio. Odds ratio. So this is the odds of Manchester winning. What is the odds of Arsenal winning the league?
Now it's 0.7.
Minus
0.6.
You
0.4.
They are right now they are number what? The league.
Number one.
Premier, number one. So, and the difference between Arsenal, Manchester City, and Liverpool is maybe 1 mark. So what is the probability that, what is the chance that my Arsenal can actually win the current Premier League?
0.7.
Say something close to 1.
Yeah, 0.9.
0.7.
But depends on whether if you are a Manchester United, the Man U's fans will say 0.1. So
Well,
who is an
it's
Arsenal
actually
fan?
0.9. Yeah, it is 0.9 because they are at the top now.
0.9. Okay. So this is a more optimistic. So what is the probability that they will lose?
0.1.
0.8.
0.8. How can it be 0.8 and
it can't be 0.8.
probability of winning is 0.9. So probability of losing is
0.1.
Yes. So what is the odds?
0.9 over 0.1.
Yeah. Or 0.1. What is the answer? (0.01). What is 0.9 divided by 0.1?
9.
9.
You see? So 9 is quite higher than. So how many times? So what we are calling odds ratio is to look at one of these groups. One of these groups, we call them exposed group. So if you are doing epidemiology, we call one of them exposed. One of them is non-exposed. An exposed group is the group which is experiencing the intervention, or the one that is experiencing the problem.
Disease.
The disease. I don't know who has the disease between Manchester and Arsenal. Who has the disease?
Arsenal.
Arsenal has a disease. So we will say, we will look at it. The odds ratio is the odds of Man City. So we divide the two. So we'll divide 9 divided by 0.25. So that we look at what is the likelihood of Arsenal winning compared to Manchester. So what will the answer is?
36.
36. So who can help us to interpret this? Arsenal is how many times more likely to win the league?
36 times more likely to win
36 times more likely
Manchester.
to win.
Yes, so Arsenal is 36 times more likely to win the league compared to. So if we are looking at odds, that is how we generate odds ratios. So that is the mathematical part of how odds ratios were developed. You know, you have an exposed group and a deceased. So you say among the exposed group, what is the odds of having a disease? So you take the number of people who are deceased, you divide by the number of people who do not have the disease. You see, then you get our odds. Then you take the people who are not exposed. You also get the people with the disease, you divide by the people without the disease. So you get odds of exposed, odds of not exposed. When you divide the two ratios, you get what we call odds ratio. And that is the way it works. Now, when you're running a regression, when you're using R and you want to model, so let us see how we can model logistic regression. I don't know whether you guys remember whether you modeled. Did you? So we need to do a table of, we need to check our variable because logistic regression will not run if you don't have a binary outcome. Do we have any binary variable? Like depression?
We need to
Gender
check the data.
or sex.
Yes, we have
No,
sex.
Sex cannot be an outcome.
Yeah, that's it.
So there's a place where we run something called depressed. Not stressed.
Yes,
not
there's a
stressed.
place with stressed, not stressed. Yes.
Can we go back and check, run it so that, okay, we have stressed, but we also had depression. Was it stressed or it was stressed?
We did stressed, not stressed. That's yesterday.
Okay. Okay, so let's run it. Let's sure that it is running. So it is called, it was here. We created a variable. We created a variable called the stressed TI underscore TI num.
And we call it stressed.
And then we call it stressed. We call it stress. I don't know what my variable is trying to say. So just try to check how your stressed variable looks like. So we can do a table and just check whether stress is there. I don't know whether I have stress. Yeah, I have stress now. So can you run that? Mine is 1 and 0. Then there's a place where we label it. Yeah, there's a place where we label it down here. I don't know what. So if you have stress, yeah, so I have stress variable. Let us also check sex or age. Let's check age cut. Do we have age cut?
We have three categories.
Yeah, so that's fine. For independent variable, it doesn't matter. So I don't have age cut here, so I have to check where it is. So please run a table of the EdgeCut if you have it.
I have, yeah.
I don't know
I
where
have
my
young adults, mid adults, and elderly.
yeah. So make sure it is there. Mine is not there, so I have to run it here. I don't know where mine is. Yeah, it's here. Mine is there. So I have done mine. Did I label it anywhere?
Mine has been labeled.
Yours is labeled.
Or the place we leveled it up, where you have stressed and not stressed.
Just check your label for stress. We made a correction, and then labeling is good because when you see outputs, it can just help you to labeling EdgeCut. I don't know why we didn't label it here. I didn't label mine, so I'm going to label mine. It doesn't matter, I mean, so long as I'll call it young. It was 1, 2, 3. Young, mid what? Mid adults.
Elderly.
Elderly. I'm just trying to run the frequency of EdgeCut to be sure that
I have not closed the bracket. Now run the first one, the first line.
So I don't know why mine is. Did I really create EdgeCut variable? Today my R is screaming, but so it's not table 1, just table. So I don't know, my R is screaming, but let's go down here and run logistic regression. So just make sure your age is there, EdgeCut is there. Man is refusing, but why is my EdgeCut refusing? So I have not run my EdgeCut vizuri. So I have to run my EdgeCut well because we want to use it for linear regression, for logistic regression.
Logistic regression.
So whose EdgeCut is running properly?
Mine is running well.
Mine is running as well.
Maybe I can share the code.
No, I think I'm running it on a different data set. So let me just run it on the correct data set. I'm running it on a wrong data set. I'm just changing the name of the data set so that it is.
Get missing.
Okay. I will ignore those red things because today they have just been telling me that they're not happy about edge cut not found. Anyway, forget about we'll establish. So let's run at least for sex was running. Let me see sex. My sex variable was okay. My sex variable was fine. Was sex a numeric variable?
No, it's categorical.
So logistic won't run. So we need a binary variable. Let's see. We need a numeric binary variable, yeah. So we have to set sex as numeric for us to do this. So how do we do that? How do we do that? We want to set it 0 and 1.
0 and 1.
Who can tell us how we do it? So let us create a binary variable for sex. So let us just use this code. So let us just put hashtag creating a binary numeric or creating sex. Let us call it sex number. So let us assign it to 0. So create a variable and assign it to null. Then create a variable, assign that sex num. Sorry, you run it first. Create a variable and call it sex underscore num. Run that. Then assign sex num to if sex is equivalent to male, is it capital M? Let me see, small m. Assign it to 1. Then repeat the same, copy this. We want to run a logistic regression. Assign it to 0. And then let us label. Labeling, you can pick one of these codes we used.
That 0 should be female.
Okay. 0 is female. Now let's label sex now. Sex numeric. How do we label? Who knows? Who can give us the code?
The code is that DP missing underscore missing your touch sex.
Which
then
sex?
factor
Which
sex
sex?
num.
Where is it here?
It was not created.
So let me just close this variable sometime. Under logical.
Check your first assigning. Depth missing underscore sex. Now it should be as now it's assigned.
Yeah, use non-zero value. I think there is some error in my code, but let me see. Just run it. Don't worry about mine. I want to check what's. Yeah, it has been created because it has missing values. You know, we did not clean the data, but that's fine. So let us label. Who was telling me how to label?
It was me, Juliet. So
yes, Juliet.
Sex num, then you factor.
You factor. You?
Yeah, you put that sign of operator,
Factor.
assignment operator. Yeah. No, you remove the bracket.
I want you to tell me. I don't want to check. What is it?
Assigning operator. You write this that sign of creating. Yeah. Then factor. Into sex num, DEP underscore missing. Comma. Levels. One zero. Labels. How do you want them to be named?
Anything.
Yeah, males, females. Yeah, then you close the bracket and run.
Okay. And then I table,
Yes.
And table. Perfect. Yeah, so now we run logistic regression. And if you look at your do file that I gave, the script here, which you are going to use, your scripts which you are going to use are here. For your practice, you will see here the three. Then I'm putting here codes for Poisson. Ordinal logistic regression is here. You can see. Some of you who will want to run ordinal regression is there. Ordinal. Then we have GLM. See? So this, when you are going to train yourself, you can run this GLM. The GLM model is just generalized linear model. You're going to put the dependent variable. Then you're going to put the independent variables, all of them. And then you're going to state family is equals to binomial. Family is equals.
Why are we saying family is binomial?
Binomial means you define, you are declaring that the dependent variable is binary, it's binomial. So there are so many families. If it is Poisson family, there is negative binomial family. It's just to state. So let us write ours. So we let us create a model 3. Let us assign him to a GLM. GLM now is generalized linear model. And a generalized linear model is a structure where you can customize that model to do several things. That's why it's general. So you, like this one, we want to fit a binomial distribution, which is our dependent variable is, what was our dependent variable? Stress. Stress. And then you put the wave and you say that it is dependent on sex. If there is another numeric variable you can add. Do you have any? We don't have. Then you can say family equals to binomial. And then you don't have to specify more thing, but you can say data is equals to, can specify the data. So this is basically but then you can actually do a summary, but the problem is that it will not give you the odds ratios. So you can write a summary of model 3. The problem, it will not give you odds ratios directly. But it will give you, I don't know, today my R is just tired. My R is tired, but can you run yours? We can run this, or we can even create, we can even run this, but I don't want to run that. Can you just run?
Yes.
Or we can, there is a package here I was calling GT summary. I don't know whether we installed it. Have you been able to run it?
No.
Yes,
No?
yes.
What do you get?
We get the intercepts 1.0, 1.4230.
Who else has been able to run it? Let me see others who are able to see an output. Who else has seen an output? I want to see as many people.
Still struggling here. I'm still struggling.
Yeah, just struggle and let's see. So I also want you to write this summary model 3, and then attach the coefficients like that. We are going to generate odds ratio. So sometimes we want to generate odds ratios. There are some nice packages if you want to tidy up your work. There is a package called Tidy. It is also a good package for making your outputs more nice. Then there's another one. Or you can just write library, you know. Even if you write library, it will install. It's a shortcut. So you can just say library. They also give you very nice outputs. Library. Install this one. And these packages are very interesting. Sometimes they sound like names of things. So let's try to run this. So I'm going to manually install it. It was misbehaving, so I will go to Tidyverse, Tidyverse. Tidyverse, I will install it. And then I will install a package called Caret. These ones just make your outputs more interesting. It is. If it's refusing, you can install it manually on the right. They just make your outputs more interesting. Then please run the logistic by writing summary, model 3, attach the coefficients. This will give you odds ratios. Who has done it? Don't worry about Caret, you know, if it's refusing, just run it. Who has seen an output? So this one we are calling logistic regression.
So this installing nice packages, is it a package under, like, I don't understand.
This package called Tidyverse. It's just a package that makes, it makes, you know, it's just like any other package, but the person who developed it for regressions just think that it produces a nice summary. There is even another one called, what is it called? Library called GT summary. This is another nice one. They are just helping to so GT summary, I can force it here. GT summary is another nice package that when you install them, they produce just good outputs. So tidyverse and GT summary, I would recommend them. They are very good. So before you learn regressions, you can always use them. They produce very, very good outputs. So you see, now it's producing very nice output. Who has seen the output? What is the odds ratio of sex?
I only saying there's no package called GT summary.
Yeah, manually install it. It will not, just go to on the right hand side, click packages, and then click install. Yes. Then manually type under the package, type GT summary.
Okay.
GT summary. It will, yeah, it will come up and then you force it. You just click install. Anybody who has run logistic regression? Model 3 was not created. So model 3, you must make sure that you have sex, num, Charles. Charles, you can speak. If you want to speak, please, I can allow you to speak.
An error.
Just check my code. So I don't even need the second one. For logistic regression, I just need to say GLM, the dependent variable plus a binary variable. I need a categorical variable, which is sex. So because we are calling it logistic regression, we need a binary outcome. If we have a categorical variable with 3 levels or 4, we can either call it nominal regression or ordinal regression. But now we have a two yes or no stressed. So when you look at the outcome down here, yes, somebody I think has posted, this is good. Who else has done it?
I'm lost. I didn't even.
I got the outcome
from the start.
Who is lost?
I am lost, Nelson.
Nelson.
Yeah.
Where are you lost, Nelson?
Right from the start, I've been trying to come up with something, but everything is just So I've been busy.
So you are the people who should advocate for an extra day. We can look for another extra day. Officially, the organizers think that we should end today, but I am always happy to be flexible if we can create another time. But I can always create time, even if the organizers say that that's the end of the training. I'm happy to create time. Just make sure that you are comfortable with your errors. But if you allow me to interpret this.
Okay, no, it's okay.
If you allow me to interpret the odds ratio. So the answer we get here is, what is the odds ratio? Who knows where the odds ratio? Odds ratio is under the first column. Who knows the answer? The value that is assigned to sex. The estimate that is assigned to sex, what is it? So Isaac is saying, how did you get sex number? So Isaac is lost. So Isaac, we created a sex num here. Maybe we allow Isaac to speak. Isaac, you can speak and tell us your issue.
Thank you. I was missing on that because I wasn't having that other variable. But I think let me just run that code so that you understand.
Yeah.
Only those lines.
Okay. So who else has run the model, fitted the model and found the answer? What is the odds ratio for sex against stress? What is the relationship between sex? The reference here, somebody is asking, was there a reference category? By default, your reference category is the 0, the value, the one with 0. Then an exposed group, the group that is neutral, the group that is not exposed, the group that is assigned value 0 is the reference. And that group's its odds ratio is 1. So the reference group here is the group that was assigned 0. What was it? Which group was assigned 0?
Female.
Female.
Yes.
Yeah. Female was assigned 0. And you can see the female was assigned 0. And therefore, the reference category always gets an odds ratio of 1.0. So when you see an output of logistic, the variable that is shown on the output is the exposed group. But the non-exposed group is always deleted from the model. So that, but you know from your experience that when the odds ratio is 1, then there is no effect. Therefore, the group that you set as your reference is a group that is not likely to have the outcome. The group which is least likely to have the problem, or the group that you think is neutral, you put it as the reference category. And by default, that value gets 1, but that reference group will be excluded from the output. So technically, the odds ratio you see here is for the exposed group. So the odds ratio here that you're seeing is 0.08. Who is seeing that? Who has seen an odds ratio? 0.085. And then there is something, the p-value. What is the p-value? I see somebody here who wants to speak. If you want to speak.
Doc, I got an output, but my output is different from what you are displaying there because my intercept is positive, and the odds ratio, that's 0.0856. Mine is negative.
No, did you put summary model $3 coefficient?
Yes.
I was also getting a different coefficient from what you have.
Yours is?
My intercept is negative 1.325.
I know what you are doing. Let me see what you are doing. I know what you are doing. Let me see. Summary. Some people are not doing what we are doing.
I did summary model _3 $ coefficient.
It can't be a negative. Odds ratio cannot be a negative. What you are doing is just odds ratio is a ratio, so it cannot be a negative. I don't know what you're doing, but let me see.
After I can share my screen so that you can see.
You see, if I don't put $ coefficient, I get an intercept of negative 1.42. Is that what you get?
So yes, that's what I have.
That is not, so that is where you do that when you are learning linear. But I've said when you want to generate odds ratio, you do the next line, which is summary in bracket model 3. You put the $sign and you write COEF, which is coefficient.
Yes,
so
I did that as well.
And when you run that, first run this and then run this. First run the summary model 3, get the negative value, and then run the next one when you are attaching the coefficients. Yeah. Run them at the same time. And the p-value was 0.008. Right. So what does the result mean? You can interpret for us. Who can interpret the result?
It means that the male individuals were 0.085 times less likely compared to the female counterpart. But that association was not significant, given that the p-value is not less than 0.05.
Yeah. So this technically means that although the odds ratio is 0.085, which is lower than 1, ideally, because we say that the reference group has an odds ratio of 1. That means the people who have males, which one has, so female have an odds ratio of 1, odds ratio of 1. Males have an odds ratio of 0.0. That means male have lower odds. Males have lower odds. So the risk of stress among male is lower than the risk of stress among so the risk of stress is lower among the male. That's why the odds ratio is lower than 1. However, the p-value here is very high, 0.08. It's higher than 5%. So what technically it means that although the odds is lower, sex is not a determinant of risk. So the risk of stress is not different between the two groups. In other words, you cannot say there's a difference between the two groups. So that is it. That is how we interpret. So there are other interesting statistics like t-tests. Maybe let's try one and then we finish. Or we just end the class?
Before the t-test,
not t, I wanted to talk about chi-square, but.
Okay, before yes. the next one, there's this, I don't know, it's called AIC or AIC, that value. What does it mean? Yeah.
Which one?
AIC. Just when we run the model, just before the summary. There is AIC. Yes, that value.
Under the residual deviance, we have the AIC.
Let me check what you're talking about. You are saying the value of EIC.
AIC.
Oh.
From the summary, yeah.
This information criteria. So this one is just telling you how, how well the model looks like. It's just something like, in statistics, we call it alkaic. yeah, information criteria. So that is just a value to tell you how good the model is. So sometimes you look at a positive value or a negative value, or sometimes you look at something called R squared, whether it's here. So that value just tells you how good the model is to predict the outcome. So sometimes there are several ways of looking at whether a model is fitting or not. So you can check the value of, there's a model summary, there is a residual value. We also have something called R and R squared. They all tell you that sometimes if it is too high, then the model is good enough. If it is too low, then the model is not good enough. It means that there could be, for example, if we had R squared, there could be other factors that are not being used in the prediction that need to be accounted for. For example, if your AIC is very low, then it tells you that sex is not the only predictor. There are other factors that you need to bring on board. That is also the same thing with R squared. So if R squared is, let's say, 90%, it tells you that 90% of the outcome is being explained by the independent variable. That means there is only a few variables that are explaining what is not there. So if a model is not good enough, it's not prediction there, your indicators showing you archaic variables saying you that the model is not good enough, it is just a red flag that you need to consider other parameters, other confounders, so that the value increases. The model is good enough, the value is doing the model is doing what it's supposed to do. However, because sometimes you see significant results, but the model is not explaining everything. That means there are other things you need to bring on board, other than sex, bring in income, bring in occupation, education, and other factors, so that your AIC value or your R square value goes up. And the more they go up, the more likely that your model is telling you what it's supposed to do. So I think we don't have enough time to continue. What we have been able to do is linear regression, logistic regression, and I can encourage you to look at the tutorial here that I have put for you here.
Excuse me, Doctor.
Yes.
Yes. I wanted to go back to Amos's comment. I seem to have similar results like his. But before you ran this, you had a comment that this code that we've written doesn't actually give us the odds ratios, that it gives us coefficients, but then you didn't proceed with it. So I just wanted to be sure whether what we are seeing in the outputs, because my results as well are interchanged, my same values, but the signs are different. I have a negative on the coefficient for sex, and then I have a positive for the intercept. Does the code give us odds ratios, or it gives us coefficients which we need to get the exponents for us to get the odds ratios?
Sorry, guy. Someone was. What are you saying?
Yeah, I'm asking whether this code that we have for the logistic is giving us odds ratios, or it's giving us coefficients that we need to get the exponentials for us to be able to get the odds ratios.
No, it's. So I think who was asking the question?
Yeah, Martin. Unfortunately, I can't.
So Martin, what we are saying is that when you run the first one, which is called the summary, Martin?
Yes, please.
When we ran the first one, which was a summary, what was the coefficient of sex?
So I had negative 0.085.
Negative 0.08562. 562. Now, can you calculate exponential of this? Can you calculate exponential of negative so that you know that those things are different?
Okay, let me do that.
Sorry. What do you get?
Just a minute.
Because I'm rounding it off. So the negative is called, when you do the logistic and you do the summary, the first one is called a logit model, a logit. Because a logit model is just producing the coefficients. The first one, actually I can write here, this is a logit model, because it is only generating the negative and positive. But when we generate the exponentials, it's going to be logistic, which is generating for us odds ratios. So you can see the value here is, I'm getting a value here of 0.918. Yeah. So it's closer because of several adjustments. Like mine here, my coefficient was, where is my sex coefficient? My sex coefficient, I don't know where my sex coefficient is. Mine has just become, mine is just now giving me issues. But who has, so when you have the coefficient, don't interpret coefficients for intercept. Interpret coefficients for sex. Is that what you're doing?
I've actually done that, but I don't notice any differences between the first model where I'm just using summary and one where I'm adding coefficient. I seem to get similar output for both.
Which will not happen. So it will not happen like that. So I run it. So when I run it, when I write the model, it should not, yeah, so that it should not happen, but I think if you rerun it, because the attaching the coefficient is just a way of creating the odds. But the summary, we had done it somewhere up here. I don't know what I got earlier. Oh, mine is not changing.
It's so funny that for me, I'm getting both to be negative, and I'm wondering.
No, coefficient of sex, not intercept.
Yes.
No, that's weird. So yeah, so the main thing is that coefficients are exponentiated to get odds. And if we want to do it, let's do it practically. I don't know, we are past time, but let us do, can we do table 1? Can we do can we tabulate sex, and can you tabulate sex? I want you to do table 1 of sex. Can you do table 1 of sex and stress? And then we can manually calculate the odds and see. So you do table 1, and then you put a wave. Put a wave and right factor. Then depression data set. Which variable are we checking? Let's check sex now. Then let's put the pipe. Then let's write the name of the stress num. Then you can write data equals to this one. We'll find table 1. Who has found my factor? Can do table 1. Who has done table 1? I want you to do what we did yesterday, where we were putting. No, it was table 1. Yeah.
You're supposed to have a bracket. Yes, that's it.
Sorry.
I think you have corrected what you did, sir.
Okay.
Yes. Sir.
So can you cross-tabulate and see unexpected bracket? So just run. My R is just exhausted. Just run. I think it's hanging, but when you run, you will be able to see. Who has run it?
I have, sir.
So okay, if you have, just tell us how many males are. Okay, just paste it here in the chat. I want to calculate for you odds manually.
I'm actually connecting with my phone. Why doing it on my system?
Okay, so okay, just tell us here. Just tell us male. So we have male. We have male, and then we have female. Right? Then yes, we have stress. We have stressed. We have not stressed. Right? Yes, so sir. How many males are stressed?
Yeah, 62, sir.
62. How many are not stressed?
962. 962.
962. How many are not stressed?
392. 3992.
3992. How many females are not stressed?
1048.
104.
48. 1048.
Not stressed.
Yes. Not stressed is 3992 also.
3992. The same.
Yes, sir. There's also missing. We have missing elements also.
Forget about missing. So okay, can we, what is the odds of, so let's get the odds ratio. What is the odds ratio? Odds of males equals to? It's
962.
Divide by? Right?
Yes, 3992.
Then the odds among female?
1048 divided by 3992.
Yeah. So the odds ratio is So the odds ratio is going to be this one, right? Divide by this one, the ratio of the two, right? What is the answer?
0.918.
Yeah. So you see, it is the same as what somebody was saying, exponential, what we got up here. Exponential. So if you manually calculate odds, the result may not be exactly. So I think the odds should be something like 0.9, not 0. So what value are we getting there? We're getting an estimate of 0.08 watts. The one we are saying was negative, was
56.
0.056. So let's try to see what is the exponential of this. 0.0856, right? So you see it's higher. Yeah. So maybe that code was not attaching the coefficients properly, but we can rerun it because it's supposed to. So when you come to this codes here, you'll be able to see what I wrote. Where did I wrote it? You'll be able to see, and you can also try this. There is also something which was developed by someone else, you know, something like this. But I don't want you to stress yourself. So it is GT summary, and it is not going to, it's going to be model _3. And it may not, because I have not installed GT summary. Let me see. Summary. So just go through, but just understand that if the model runs perfectly, then odds ratio is a number between 0 and 1. It's just a ratio. So it also gives you information about, it just gives you information about how likely one group is to get the disease, or to get the disease. So in this case, we are saying that there's no difference between male and female in terms of their risk of getting stress, because our p-value was quite high. It was more than 0.05, and therefore sex is not a predictor of stress in this case. So, ladies and gentlemen, time does not permit us to continue. We've tried within the time we were provided to come this far. Usually it is doing even up to statistics on the third day. You're able to do some summary statistics. You're able to plot a few graphs. You can go and check the script that I've written here for you. And then you can practice. So yeah,
Sure.
so this will mark the end of our class. I can open up this for you.
Vincent?
If you want to speak, yes.
Okay, I was just checking with other project members if we can be able to have more time. And we think we can have some time in June, maybe to continue some sessions if you will be available.
So the other classes like Python, I don't, were they given more time? But it
No.
doesn't matter. I'm happy to give you time.
Okay, okay. So we will communicate. So don't worry, but keep on practicing what we have learned today.
And make sure you go to the tutorials that I have already written, also the do files. It's not do file, the scripts. So anybody can go and practice. Otherwise, this marks the end of our.
Can we?
Sorry?
The GT summary code